Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 tonight flight from Zurich International Airport. Then we will find Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 144 Lszh, localized and landing zone on the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments that displays and the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb of the aircraft in tens, hundreds, and thousands feet per minute, of the steepness of the trigonometric angles in decrease and climb descent, the artificial horizon of the indicator, the pitch ladder in decrease and the bank angle in decrease, the ILS localizer, the horizontal localizer, and the vertical glide slope that receives the radio frequency transmitted from the threshold antennas of the runways in the airports we use for takeoff and for landing, and receives with the onboard antennas. So we have the ILS localizer of the Zurich International Airport, the Lszh in Switzerland, runway 14 ILS localizer, instrument landing system frequency, radio frequency. So you'll see that here in the primary flight display. We have also the ILS localizer crossbars, the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the flight mode annunciator with the autopilot and the auto throttle, lateral and vertical navigation modes. We have also the HSI, that has the horizontal, it's this horizontal situation indicator. It has the heading of the aircraft, the magnetic heading and track. We have the magnetic north pole and geographic north pole, magnetic variation also depending where around the world, displayed in the navigation display. The navigation display that displays the GPS position, also the terrain and weather reflections from the weather radar. You can see the terrain with red, green, and yellow color displayed, also with blue the sea level, the lakes, and the rivers. We have also the airports, the 4-letter airport name for each airport, where it's located, the distance. We have the distance displayed in nautical miles in the navigation display, so you can calculate when you travel how far away, maybe if you don't have the fine management computer, an airport is located from your position or another aircraft in the air. So we have also in the navigation display, you can see hazardous during the weather reflections. We have also the airports, the navigation aids, the nav aids, the horizontal and vertical navigation waypoints. The aircraft will not have to transverse through some waypoints as we're going to be flying. I'm going to use the flight management computer to create a flight plan or a flight path or a route, so you will see how I'm going to do that using the flight management computer. And we're going to be flying. The aircraft will be following the flight path created. If we turn on the autopilot and flight director system panel with the LNAV and the VNAV, the lateral navigation and vertical navigation that takes the data created from the flight management computer when we create the flight plan. So you will see also in navigation display, we have, as I told you, the work stations, ADFs, and DBs, waypoints, which are navigation aids. We have the display of other aircraft that fly around our own aircraft. You can see how far away the other aircraft is located. We have the transponder, the ADSB and ADC, transmitter receiver that transmits our frequency to other aircraft, and the air traffic control and receives from other aircraft. And I can calculate using the radio frequency receiver of the transporter. Using its computer, you can calculate the other aircraft distance from our aircraft, whether they climb or descend with respect to our aircraft. Also, you can calculate the velocity difference between our aircraft and the other aircraft. It will make a warning if we have an incoming collision in the air or in the ground. So we'll make an avoidance maneuver in the air using the TCASIS and traffic collision advisory system. So we have also, you can see the terrain map as I told you here with the airports. You can see the runways also when we create the flight plan. You will see the runway we're gonna use for takeoff and for landing. So I will show you the displays of the Boeing 787-900 jet aircraft, also the outside, the flight controls before we're gonna make a complete flight from takeoff, climb, cruise, descent, approach the line. In the end part of the video, you will see the complete flight of the aircraft. After I make an explanation for all the systems and make an engine start demonstration. So you will see also the autopilot flight director system panel, the primary flight display over here, the navigation display, the flight management computer, the thrust levers over here, and the flaps, the slots, the speed brakes, the flight controls over here, the control column for climb and descent, and the control wheel for making turns left and right, and also the rudder pedals for the vertical rudder, the vertical tail, the horizontal stabilizer, over here the elevator for climb and descent. You will see the thrust levers, how I use the thrust levers also, increase and decrease the engine thrust over here. So you will see the thrust over here produced from the engines. We have the N1, exhaust gas temperature, N2, a fuel flow parameters per hour, oil pressure, oil temperature, oil quantity, the vibration of the N2 stage of the engine, the outflow air, also the bleed air from the engines that applies the cabin pressurization system, other systems like the hydraulic fluid tanks, wing and engine anti-ice, air conditioning, ventilation. So we have the N1 over here. I will explain you later the engine's indications. I will start maybe with the primary flight display. You will see the airspeed indicated over here, the airspeed tape, the airspeed selected from the autopilot flight director system panel, the barometric altitude above the sea level, the vertical rate of climb and descent of the aircraft in tens, hundreds and thousands feet per minute. You can see how fast the aircraft can climb or descend. The radio altitude above the ground level, the flight director over here, the crossbars, and the pitch altitude 2.5, 5, 7.5, 10, 12.5, 15, 7.5, 20 for pitch up or pitch down, and also the bank roll in flight, the bank angle. We have also the heading selected and the actual heading of the aircraft over here. You can see the angle is like 30, it's more than 30, it's 31, 32, so it's like 40 degrees right now of difference. So you can see the selected values here from the autopilot flight director system panel, 200 knots, the airspeed indicated, speed selected actually, for flying the aircraft. You will see later, auto throttle engage and disengage, autopilot engage, disengage, flight director. We have the modes and nav, VNAV, flight level change, auto throttle, climb continues, the heading, bank angle, heading guidance, vertical rate of climb descent, altitude also, all the aircraft as we fly. So you see autopilot flight director system panel, flight management computer. Over here we're gonna create a flight plan using this system that has many functions. We have the mouse pad for controlling the cursor also. We have the trim stabilizer for the horizontal tail here and here. You can trim the aircraft as we fly. You can see fuel control for the left and the right engine, fire extinguishers, pull-out and switch, transporter, rudder trim. This is the rudder radio management panel over here. Has the navigation and communication radios. You can see also the pitch trim, the landing gear, extender, retract. Over here I will show you one system one by one. So you will see the navigation display later. I will show you the flight plan also, the terrain, how far above the ground the aircraft will be flying. Over here we'll make some changes in the display, what values we have selected. You will see also the overhead panel, the electric, hydraulic, fuel system, electronic engine control for the engines, pressurizer, cabin pressurization, pressurizer system, leader system, and here is flight control computers and air data computer. You will see later. Now many of the systems we're gonna use. So I will show you all these systems. I will make an explanation of each system one by one. I'm showing you right now the primary flight display in the HSI. So you can see here, as I told you, the airspeed selected and the altitude selected. It's the same like the values here in the autopilot flight director system panel, also the heading. You will see everything displayed here. Radio altitude. So we have the pitch altitude in flight, the bank count, the vertical rate of climb descent. This is vertical speed indicator. This tape and this needle you see moving up when we climb or down when we descend. The barometric altitude right now 1,430 feet. For this barometric pressure 39.92 inches of mercury. The radio minimums. You set the barometric pressure over here. Baro set inches of mercury of hectopascals, and the minimums radio, the range of the plan over here, and the range weather radar, traffic and terrain on the displays. This is for the navigation also display, weather radar and terrain and traffic. And here is cancel, reject or accept some warnings. Some you can see here the warnings from the ACAS, for instance. So we have also the display of some systems over here. CDU, info, checklist, communication, ACAS used later. In the displays over here or here, you can select either one. We have, as I told you, thrust levers. Over here, the thrust produced by the engine. We have also the flaps over here. You will see the flaps fully extended or fully retract. You can see the handle. It will move up now. So I will extend one by one. 5, 15. Over here you can see how many degrees we have it. 25, 30. Fully extended. The speed brakes also. So you will see the flaps position right now 30 degrees fully extended. We have the transition also. Fully retracted, fully extended. One gear also. So I will show you one by one the systems of the aircraft of the Boeing 787. So I will make an explanation also about the aerodynamics of the aircraft. Before I show you the flight controls, I will talk to you about Newton's physics, aeronautical and aerospace engineering, Bernoulli theory of fluids, Newton's physics, mechanics, and derive some principles and some equations we need to know for the air transport pilot license also for flying the aircraft. So here you can see the outside view. You can see the wings here. Hold the aircraft weight as the aircraft flies, the surface area of the wings, the forward wings mainly. We have the thrust from the engines that moves the aircraft forward. You can see also we have the mean aerodynamic chord position, the Mach, which is 23% of the aerodynamic chord of the aircraft. It's the position where the maximum aerodynamic lift occurs in the forward wings. It's also the position where the stall will begin in the top surface of the wings when we fly. So we need to monitor over here the stall speed. You will see the airspeed of the aircraft when we fly, and we have also the stall speed for a given angle of attack. You'll see the yellow and the red indication down here below the airspeed when you fly. We need to have an airspeed always above the stall speed. So the stall will develop behind here mainly. We have also the deflections, as you see the flight controls. So here is also the mean aerodynamic chord position. It's pretty much where the center of gravity, the vertical axis, will be located. We have the rudder for making turns around the vertical axis or the center of gravity, the yawing control, as you can see. We have the elevator for climb descent over here, as you can see. So you can climb and you can descend the aircraft like this. This is the elevator axis, the pitch axis of the aircraft, transverses the wingtip to wingtip. When we have the longitudinal axis from nose to tail, is the lateral or bang roll here, the roll axis. that uses the ailerons and the spoilers to make turns on the left and right wing. So you can use all controls together to make coordinated flight. We use only aileron spoilers, for instance, or rudder or elevator. So we have this longitudinal axis here, the vertical axis, the lateral from wingtip to wingtip, and we have also the elevator pitch trim. You can set, as you see, the elevator for climb descent. You can also use the pitch trim. I will show you inside the switch. You can pitch the aircraft up or nose down by trimming the elevator up and down, or the horizontal tail in total in some other aircraft. So you see, also we have the rudder trim. You have the thrust that moves the aircraft forward from the engines, the thrust vectors. We have also the wings here. You can see the bottom surface of the wings is more flat. So when we fly using the Bernoulli theory of fluids, the airflow is moving slower below the wings, and we have also the flaps extended, and we may have an angle of attack like this. It will make the airflow moving slower. And we have higher pressure, which pressurizes the aircraft wings up into the air, so it will make the aircraft weight up into the air with the wings. So we have also the top surface of the wings, you can see it's more curved. So using the Bernoulli theory of fluids, the airflow will be moving much faster above the wings, so we have lower pressure, which sucks the aircraft weight and wings up into the air. So this is basic aerodynamics and flight dynamics you need to know when applying the thrust and control the aircraft using the flight controls here. So to use the control column for climb descent, the control wheel make turns left and right. As you can see, the flight controls. I will show you another view of the flight control system. Maybe better view like this. So you see, I'm using the side stick for the airbus to control the yoke and the rudder pedals of the Boeing. There's no problem with that. We have the same output in the end. So you can see it's a fly-by-wire aircraft. The side stick or yoke moves electric flight control computers. So we have the flight control computers over here. They have the normal and alternate mode, and we have direct mechanical mode also. Primary flight control computers, as you can see, need to be in the auto position over here. So we have also the automatic trim of the aircraft. We can trim the horizontal tail, as I told you, when we fly. We can trim up and down the horizontal tail of the aircraft for climb descent. We can also trim automatically using the auto trim function of the Boeing 787. So I will show you a couple more things about the Boeing 787 cockpit before we're gonna make the engine start demonstration. I will show you a couple more for the flight controls. You will see how I use the horizontal trim stabilizer also. The thrust levers, the flaps and the slats, the speed brakes. Maybe perhaps, as you can see, the side stick deflection is proportional to the yoke, the flight control. So you use the control column here is the elevator only. The horizontal tail for climb and descent, horizontal tail. Control wheels for ailerons and spoilers left and right wing, make turns left and right. It's pretty simple. And the rudder pedals over here, you make the left and the right side rudder, the vertical tail of the aircraft, move the aircraft left or right. So we have also toe brakes in the rudder pedals and the nose wheel steering. The nose wheel of the aircraft is controlled by the tiller and also by some rudder pedal input until we are having an acceleration for takeoff like 70 knots. We have some input that is decreasing linearly from 76 degrees to 7 and then to 0. And we have the rudder aerodynamically effective like in 45 knots usually in most airline aircraft. So pretty much the same for all of them. So you can use also, so I will show you also this view of the flight controls. Then I will make the flight management computer maybe. So I'll show you now this view also of the flight controls of the Boeing 787. I hope you like it also. maybe more clear view. So you can see you can climb and you can descend like this. Maybe we need to fix the screen view. So you climb, you can descend, you can make turns to the left, turns to the right. You see here we have the side stick like the Airbus to control the aircraft flight controls in flight. So you can see the side stick deflection is proportional to the yoke deflection. Both sides move together, they're interconnected in the flight, the captain and the first officer. Unless you have a failure, like in the Airbus, you have the side stick priority. We have also the horizontal trim stabilizer here. So full flight controls and also thrust levers over here. As you can see, you can apply the thrust forward and aft. Your idle thrust. We have the thrust reversers also for slowing down the aircraft. So I will show you also this view. We have the outside view over here. With this view you can see maybe better. Climb and descent. The horizontal tail of the aircraft. Climb and descent. Here you can see the rudder. It turns left and right. You can see also irons and spoilers. Left and right turn with the spoilers retracted. You will see there. So this is the main principle of the flight controls of the Boeing 787. So I will use the flight management computer now to input the data of the aircraft for this flight. Also, you also forgot over here the flight controls. We have one more thing, the control column. You see we have the horizontal trim stabilizer. You can trim down or trim up. This way you trim up is the elevator trim. So I need to explain also this system. You can see elevator trim, left click down, right click up. So left click, this way you trim down the aircraft as you fly. You trim you pitch the nose down, and this way you pitch the nose up. This is the effect you have using the elevator trim, the horizontal elevator, the horizontal trim. So you trim up mainly. This way we have the autopilot disconnect here, elevator trim, and the head-up display, the clutter. You can see the flap limits also here, some other multifunction display. So I will show you later. Maybe we have time. So the main thing with the flight controls, you trim the horizontal tail like that. Using this switch is the manual trim channel, the manual channel of the flight control computers. You have also the auto trim using the autopilot flight director system panel, the auto throttle, and also which has an alternate manual trim switch over here, you will see later. And we have the auto throttle. We have the horizontal stabilizer cutoff switches here. So if you have failure of the hydraulic systems that affect the L2 and R2 horizontal stabilizer, we have a malfunction of the automatic trim from the autopilot flight director system panel. So you need to come here and open this guarded switch from normal to cut off, as you can see, L2 and R2 horizontal tail trim stabilizer. This disconnects the auto trim function. So this is for the left and this is for the right horizontal trim stabilizer. So you need to remember that. This is for all Boeing 737, 747, 757, 767, 777 and Boeing 787. We have after that we have only the manual trim control. We have also the alternate channel. We have dual channel redundancy for the manual trim. So you have the nose up here, nose up trim, and nose down trim effect, beats up actually. So we have also the parking brakes, this handle here. I will show you later. Fuel control, left and right engine. I'll show you the fuel control later. We're gonna make an engine start demonstration. The thrust levers over here, the auto throttle, disconnect switch here, the takeoff ground, auto throttle disconnect, takeoff ground, thrust reverse, speed brakes here, extend and retract, I told you, and the flaps again, one more time. I'm gonna set them for takeoff later. So I will show you the flight management computer. I will input all the data of the aircraft for this flight, the takeoff gross weight, the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing, in the center tank, how much we have it, 30% in the left wing, 30% in the right wing, and 10% in the center tank. So the flight management computer will calculate also the loads from the passengers and the cargo compartments automatically. It will give us the center of gravity of the aircraft from takeoff, climb, cruises, and approach and landing. As we fly, the aircraft will be burning fuel, so you will receive the center of gravity in flight. Is recalculated automatically. Also, this affects the horizontal tail trim stabilizer that I show you. This trim switch here that you use to trim the horizontal tail of the aircraft up and down, or adjust the elevator in this aircraft. So you can see this will calculate the flight management computer, also the aerodynamic core position, 33% of the Mach. It will calculate a few more things, the center of gravity and the horizontal trim stabilizer. We're gonna use the flaps for takeoff 15 degrees, and we're gonna select the runway we're gonna use for takeoff in the Zurich International Airport, the Lszh. It's in Switzerland. The runway 14, we're gonna use the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, the temperature of the air, and the flaps we use for takeoff. The flight management computer will give us the takeoff speeds, the V1, V-rotate, and V2. It's gonna be like 130%, 130 knots to 140 knots for the V2, and maybe V2 plus 50 knots is gonna be 155, 160 knots. So we're gonna have flaps 15 degrees, and we're gonna pitch the aircraft nose up like 9 degrees for takeoff. Then we're gonna have in the flight management computer, we're gonna create the flight plan. I'm gonna use from the runway we're gonna use for takeoff. The seats are these other instrument departure waypoints and fixes that include horizontal and vertical navigation fixes for the initial climb and departure of the aircraft, and altitude and airspeed constraints. We're gonna have the climb to the cruise level. We're gonna select a cruise level at 35, 36, 37, 38, 39, 30,000 feet above the sea level. Cruise over there, cross through some waypoints. Then we're gonna have the top of descent. We're gonna initiate the descent back to the elevation of the airport. We are 1,430 feet, so we're gonna descend to like 6,000 for the terminal approach and landing, 6 and 7,000 above the sea level. So we're gonna have the stars, the other terminal arrival waypoints and fixes that include horizontal vertical navigation fixes and airspeed and altitude constraints for the terminal, the long final and the short final approach. So we're gonna have also the Ilsloc localizer for this runway, the runway 14, as I told you, in Switzerland for approach and landing in the Lszh airport, and the Ilsloc localizer for this runway. We're gonna have the horizontal localizer, the vertical glide slope to align us with the magnetic north pole heading of the runway 14, that is 136 degrees magnetic north pole heading. For the horizontal localizer and vertical glide slope for the vertical profile of approach. We're gonna have the flaps extended to like 35-30 degrees. The landing gear extended and pitch attitude to like 9 degrees for approach and landing, and an airspeed of about 160 knots. So you will see all these things. We will be flying the flight controls also manually over here, as you're gonna see, for approach and landing. So So what I miss right now, I need to make up the flight management computer. I will show you the flight plan we're gonna create over here. Then we have a few more things to do before fly. So you see the autopilot flight director system panel, also the displays. So you have the model here, the index, identity, position, performance, takeoff, approach, annunciate status. Over here you can select either mode, navigation, data, flight plans, load ATC, route, load plan, save flight plan. So we have position also, index. You can use either one, move with the mouse cursor. You can see the purple. It indicates where I have my mouse cursor pointing up, what selection I make. I use also the alphanumeric here, so I have a mouse pad, as you can see here also, for controlling the mouse cursor. So you have the index, identity, Boeing 787, GNX engines, position here, Lszh airport in Switzerland. This will give us the GPS, nearest GPS, also last position, coordinates. So we have performance, takeoff, approach. We have the performance here, takeoff, gross weight. So I would say before that the route. So we have Lszh, the departure and arrival. Airport over here, Lszh, back to Lszh. Over here, as you can see, copy paste, runway 14. Select the runway for takeoff and for landing later. So we have departure and arrivals over here page. You can see departure, arrivals, alternate route, legs, initialize. So we use either page is convenient for us for creating the flight plan. So we use the departures now. We select either runway 10, runway 14, 16, 28, 32. So we'll select runway 14. And the seats, the start instrument departure waypoints and fixed. The left side are, as I told you, you will see the stars displayed in the navigation display. The initial waypoints and fixes for the departure of Lszh approaches now. As you can see, so we can select VOM 16, VOM 28, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 2834. So either one runway. So I will select ILS 14. I will select Trans Amity, this transition waypoint. So we're gonna have also Negria 1 Alpha, the stars are the star terminal arrival waypoints and fixes for the terminal approach and landing of the aircraft. So you'll see the stars displayed. We have now the waypoints over here from 1st, 2nd, 3rd, 4th, 5th, 16th, 17th, 18th. So we have 18th, 19th, 20, 21, 22, 23, 24. So we have 23 waypoints we need to cross through until we reach the runway for landing from takeoff. So each one has a different heading, a different altitude, airspeed. So we're gonna set all these things now. The route legs. So we set here 0 fuel weight, fuel on board, calculations, gross weight for takeoff, reserves 5% over here, cruising altitude 25,300 feet, cost index over here 100%, fuel freezing temperature over here minus 37 actually decrease, and the center of gravity 38%. So we need center of gravity in flight, and also we need to recirculate the fuel in flight. It won't freeze, so we execute, and this activates over here the flight plan with the route, airspeed and altitude. We have fly through in cruise. So we have the first waypoint 135 degrees, 250 knots, 1900 alpha, 2 nautical miles. Third one 1 nautical, 3, 5, 6 the Zui, 6 nautical miles from the previous one, 300 knots over here. The airspeed 6000 alpha, Then we climb to the cruise level Negria 071 heading 26 nautical miles, 301 knots, flight level 22,200, matic 320 knots. We start the descent here, 12 nautical miles, 11,800, Amity 258 degrees heading 6 nautical miles away, 190 knots, 10,400, Zui 180 knots, 7,000 Alpha, 9 nautical miles away, Z8701. Here's the stars, the start of terminal arrival, waypoints and fixes for the terminal approach and landing. So you see active route legs again, TRA 180 knots, 5,000 Alpha, CI 14 235 degrees, 6 nautical miles away, 180 knots, the airspeed 4,000 Alpha above the sea level, Osnem 136 degrees, same heading like the runway, 5 nautical miles away, 174,000, runway 14, terminal on 136 degrees, 8 nautical miles away, 140 knots, 1,455. So this is the route we need to use. We're gonna use 15 degrees also flat, center of gravity 28% over here, 33 for takeoff with 4.25 degrees. In flight it's gonna be 28%. So we have V1, V rotate, the takeoff speed, and V2 140 knots, gross weight takeoff 357,000 pounds with 35,000 pounds of fuel. So this is all we need to do. Initialize, route, departure, arrival, alternate. We can use an alternate plan. Active VNAV, also over here, progress, FMC communication, holds, we can hold in a waypoint in flight, fix, we can set up fix, navigation radio. So this is all the things we need to do before going into flight. We have the active flight plan or route over here for the aircraft to fly through. So a couple more things very fast. I will show you now the navigation display and the primary flight display, the difference with before. Now we have also the flight plan displayed. So you see the horizontal and vertical profile, also the flight plan and the waypoints in displays over here. So you can see again we have takeoff, ground, flight director, pretty much the same things. We have over here the differences. We have the flight plan created, so you see the waypoints from takeoff, climb, cruise, descent, approach and landing, the ADFs, workstation, GPS also setting, magnetic north pole heading. So you see better the plan over here with the terrain map, the elevation of the mountains, how far away they are, displayed the airports, also the Germany here, the France, and the Switzerland down here. So you will see also the route we have to follow in flight. You can see displayed with purple. You can see the elevation of the terrain here, the mountain. You can see the terrain also in front of you when you're flying. You need to avoid, so you can see how far above the terrain the aircraft will be flying. You can see also this purple line is the climb rate. It's the climb we need to do for the cruise level over here for the flight plan. When we depart, you can see the terrain in front of you. You can see also the runways if we look closer. You can see magnetic north pole heading. The range now is 20 nautical miles. So we can look closer, like 10 nautical miles, 5 nautical miles, 2 nautical miles, 1 nautical miles, half nautical miles. So here you can see the runway better, and the taxiway in front of you, the other runway, the terrain also. So this is the runway. We have the taxiway in front of us. It's displayed here in the GPS. This curve, also the runway we're gonna use for takeoff and for landing, displayed here. The other runway on this side. If you look outside, you will see the runways and the taxiways and the terrain. So it's like on the GPS display. So you will see same runways and taxiway over here. So we can look further away again. You will see a better view of the flight plan. Maybe we'll look at the center over here. Yeah, now we have better view. You can see the lines that are connected when we're gonna be flying. The waypoints also we selected from takeoff and climb. This is the descent here, approach landing again. So we look further away, we see the Amity, then the Negria. We have to cross through here and fly. Mative. So here is better maybe to look at the plan again. The other side. Display over here the plan. Destination, cruiser, terrain again. Set map, centering. So this is for navigation purposes. You can see the furthest away waypoint, the Nigria, Mative, Amity, then descent, approach, and landing. Also takeoff here from this runway. This is the same waypoints we have selected here in the flight management computer. Zuri, over here the active flight plan. So you can see everything is working the way it should be. And the airport also display. So I hope you like this navigation display. Again, the runway we're gonna use for takeoff and for landing. The intercept as we fly. A little closer, look further away. So look at the map again. Over here, better view for takeoff. So we have also the engines, the left and the right engine indication over here. You can see the N1, which is the low speed starter and SAFs. I will talk to you now about the engines, the GNX engine. We have the GNX engines installed, one in the left wing, one in the right wing, for symmetrical thoracic dilatation, one contains gearbox of the FAREX are the full authority digital electronic control computers, one installed per engine gearbox, goes down over the data sheet, one for each, the other takes over control, displays over the data. You see displayed from the FAREX, like the N1, which is the low speed starters have low pressure, compressor, and turbine with the turbofan, which is engine, the exhaust gas temperature per engine. The N2, which is the high speed starters have the high pressure, compressor, and turbine with the turbofan, which is engine. The fuel flow per inch per 1,000 kilograms, 1,000 pounds, solid pressure and temperature, quantity, and the vibration of the N2 stage of the engine. The FAREX also control the outflow valves of the 5th and 9th stage, the pressurizer from the engines, the bleeder, also from the bypasser from the front fan. So we have bleeder for cabin pressurization, wing and engine anti-ice air conditioning, ventilation, also for hydraulic fluid tanks pressurization. So you see when we move the flight controls are controlled electrically, but the flight control surfaces are controlled hydraulically actuated. So we need hydraulic pressure from the engines, pressurizer, and pumps the pressurized hydraulic fluids over here. You will see later in the overhead panel. So you see the engines here. Also we have the pressurizer over here section, the cabin pressurization system. In the manual mode, you'll see what it displays over here. So the FAREX do all these amazing things. You can see the N1, which is the low speed starter SAF, low pressure compressor and turbine with the turbofan, which is engine at idle 19.8%, 99.6 takeoff limit with green, red and yellow never exceed. Exhaust gas temperature, N2, which is the high speed starters have high pressure compressor and turbine with the turbofan, which is engine. Fuel flow per engine per hour, 1,000 kilograms, 1,000 pounds, 1,500 per engine per hour. Oil pressure, oil temperature, oil quantity, vibration of the engine stage of the engine, the outflow valves here, flaps, stabilizer trim, rudder trim, landing gear, alternate gear, also some more things we can see here, lock override, auto brakes here, you can see projected takeoff for landing. We have gross weight for takeoff over here, total fuel on board and the fuel temperature. So a few more, this is the main things we need to know about the engines. Also, as we the FAREX control the fuel heat exchange sensors. When we fly, we need to recirculate the fuel from the left and the right wing and center tank into the engine to heat up the fuel. And also we do the same for the lubricant and the oils, because the fuel we're gonna freeze in flight. We have the automatic oils recirculation controlled by the FAREX, the fuel metering unit. Also engine start, engine shutdown, engine failures. Also, as we fly from the sea level all the way up to the cruise level, it's 35 to 20, 30 or 40,000 feet above the sea level, like 8, 9, 10 or 11 or 12,000 meters above the sea level. As we climb higher, the aircraft will be flying, the pressure of the air, the density and the oxygen level are becoming less than half than that of the sea level. Also the temperature of the air becomes freezing, like minus 30, minus 40, minus 50, minus 60 degrees Celsius. Also the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level as we climb higher. So we're going to have a higher intake of airflow from the front fan for compression from the engine compressors, like combustion then with a fueler mixer. So we need a different fueler mixer request adjusted every second from the FAREX automatically from the full authority to use electronic control computers. Also as we descend back to the airports, it's also done automatically from the FAREX, not like doing in the propeller aircraft. So it's a good thing to have the FAREX installed into your engines. Also, a couple more things here. The battery, 28 volts direct current. We have the left and right IDG, the great drive generator. We're gonna start the APU now to start the engine. 120 200 volts, 400 Hz frequency, 120,000 kilovolts. Primary flight control computers at auto. Air data computer. This is controlling GPS receivers, magnetic north pole, true north pole, pitot, static, pitot, dynamic, the airspeed and the altitude of the aircraft. Laser gyroscopes also. So all air data are controlled from the data computer here. Flight control surfaces, Towny power, FD door, passenger oxygen over here, window heat, primary turbine, hydraulics, left and right engine, hydraulic pumps. Turn off the primary with mount the engine driver. You'll see what happens. Turn back to the on, then to the auto position. We have the wing and engine on the ice here. Set beyond the ice at auto or on. We have the recorders, the cargo and APU fire, electronic engine control for the engine, left and right engine with the normal and alternate mode, and the auto start. You'll see later how we're gonna start the engines. Fuel jettison, get dump some fuel in flight to lose weight, make an emergency landing, refill nozzles, how much remain. Left and right wing, fuel tank, center tank, balance fuel and crossfeed valve off. If we turn it on, you can feed either engine with either pump or either tank. So this is the fuel system. We have also the pressurizer, the packs from the left and right engine, cabin pressurization, wing and engine at the ice, air conditioning, ventilation. This is cabin pressurization here. At manual use, the outflow valves open and close. Pressurize the camera. At automatic, you have to do nothing actually. So I will show you one more thing before going to takeoff. We need to set up here the autopilot flight director system panel. You see the displays here in digital format. All the systems using the overhead panel. So you can see here we have the hydraulics, the APU, oxygen, liquid cooling. So you can see which system is working and how. From the overhead panel, the APU is running. This is the electric left and right engine ADC, 120 200 volts, 400 Hz frequency. The main battery, 31 volts, the amperettes, the load cell, the APU also, hydraulics, where the hydraulic fluid goes, which system use it, primary demand, pump shut-off valves, also 5000 psi each left and right and center, electric C1, C2, how much hydraulic fluid you have. The fuel system over here, you can see left and right, wing, fuel tank, center tank, 11,000, 11,000, 11,000, total 34,000 pounds. Low and high pressure fuel valves from the left and right engine are open and feed both engines from the center. The APU is fed from the DC motor from the left wing. The crossfeed valve is off, but if we turn it on, it can feed either engine with either pump or either tank. Also, you can see the minimum fuel temperature here, below which the fuel is freezing, so we recirculate from the wind tanks and the center tank the fuel to heat it up. You can see here minimum fuel temperature, minus 37 degrees, and the fuel temperature right now. It will freeze in flight. So the air system, pressurizer from left and right engine, the PAX controls, doors. You can see the doors are closed, the cabin can pressurize, the brakes and the temperature of the tires and the pressure of the tires, the nozzle. Also flight controls. Here you can see all flight controls are moving together as they should be. The rudder also, the limit, the elevator, the tail of the aircraft. So you have to have the flight controls like this in a proper condition when you fly. You will see over here indicated also ailerons and spoilers, how much they deflect. So we have systems here, last system, FS display over here, maintenance, circuit breakers over here, also automatic, checklist, last thing to do before takeoff, after takeoff, approach landing, communications over here. So we have the navigation display over here. We need to restart the engines right now. Γεια σου, τι κάνεις, καλά? Ναι, ήρθε, αλλά δεν είπε τίποτα, ευτυχώς. So we're gonna shut down the engines right now and see how we're gonna reset the aircraft. So we turn off both controls over here. Both fuel flow to the left and right engine. Turn it off like this. Both left and right engine is off right now, so you will see the engine's indications. We have some systems are going out. So if we look outside, you will see the engines are going off, and we have 1 more minute to set them up to restart. So you can hear the rotor is going down, so we need to restart here these switches, auto start, left and right on. So this will gonna admit pressurizer from the APU, the smaller turbine in the tail of the aircraft, into the left and the right engine bleeder system. So you'll see only the pressurizer here, and 2 is increasing above 20%. You will hear the roar again. We have only pressurizer. We can turn on both fuel control here, as you can see. So both fuel control left and right on, and we have the auto start is kicking in. We're gonna be flying in a couple of seconds. So 39, 30, 31. So you see the systems now going off as we have the increased engine power. So above 60% is gonna be automatic auto start on. So we have the running engine, both left and right. So we're gonna set also here the airspeed 250 knots. The heading, one last thing. And we're gonna set the altitude later when we'll be flying to save some time. So we're gonna set the magnetic north pole heading 136 degrees. So we are ready to go for flight. Disarm the parking brakes, use flaps over here, and we're going for takeoff. And we have 18 more minutes for the video to end. So we increase the power of the engines. So we take the air traffic control, the clearance, and we taxi into the runway for takeoff over here. So we align using the tiller over here. So this is how you align here, using the tiller. So we advance the engine power, the takeoff go around over here. Maximum takeoff power, 15 degrees of flaps. You can see we need to pressurize a little bit the yoke down until 100 knots, 80 knots, 90, 100. So at V1 we rotate along with the rudder pedals, we pitch up 9 degrees, very small pitch up. So we have the positive rate of climb and keep accelerating the aircraft. So landing gear up over here, keep climbing, maximum takeoff thrust, as you can see. So here you see we take off. You see we are 2,500 feet, 2,400 above the ground, but 4,300 above the sea. You can see also the airspeed 193 knots. Also the stall speed, the flat speeds over here, 5,000 feet above the ground, above the sea, and we climb with 5,000 feet per minute. You can see the trend line now. Also the pitch altitude is like 20 degrees. You can see also how far above we are from the ground over here as we fly. You can see the aircraft symbol. We are 4,000 feet almost above the ground. You can see the terrain in front and around. Also, we will look a little bit the engines indications as we climb. So we cross 7,000 feet. So you can look further away. You will see again red, green, and yellow colors, indications from the terrain. So we look at the flight plan now as we're climbing. So this is the initial climb of the aircraft, as you can see. You can see the airport behind the lakes here, the Switzerland, beautiful Switzerland view. So we need to go back. We're gonna make the turn now to the flight plan. Also use a little bit rudder, left rudder to make the turn. So we need to climb a little bit higher. We're at 12,000 feet here. You can see the airport again, where we are located. So I hope you like this view, very beautiful, the Switzerland. Also the galaxy here, other aircraft will fly around you. So this is a unique view, the Boeing 787. So this is the view of the aircraft after takeoff over here, as you can see, the cockpit. So I need to make a turn here. We need to cross through this waypoint here, so we align a little bit. And we have 12 more minutes for the flight to end. Maybe we're gonna accelerate now the aircraft to a higher airspeed. to avoid stalling. Here you see how it stalls. It goes into stall if you decrease out the flaps, but you increase out the airspeed in the end. This is a good thing to have higher airspeed also. So we need to make a right turn now to cross through all this waypoint in a couple of seconds. You can see we can fly it off, fly with hands off. The aircraft flight controls, we are trimmed in the right way. You can see here also again a nicer view, the galaxy again, the Switzerland, Swiss Alps. Over here the lake, we have the Germany, my homeland, in front of you, the Bayern Munich and the France and the galaxy. To keep flying. You can see also the engine's indication here. And we have 10 more minutes to go, so we need to take the turn now over here. So this is how we make the turn. You can see, so the outside view, overflying the lake here, the Germany, Bayern Munich in front of you, the lake and the Switzerland, the Swiss Alps over here. So we have Boeing 787, 32,000 feet over here. So we have 10 more minutes to go back to the airport as we're climbing. We can use some right rudder for this turn as we're turning. We're not having too much airspeed to affect the rudder right now. So we need to align over here, and we're gonna start the descent in a couple of minutes back to the airport. So this is how we level off over here. You can see the cockpit, nice view, and also everything outside. We're leveling off, and we need to start the descent in a couple of minutes. Also we're gonna have the handrails now. You can see this beautiful view, the frozen vapors from the tail of the aircraft over here. So we have the Germany behind us, the lake, the Bayern Munich, the France, the galaxy over here. So I hope you have the most nice view of the chemtrails of the Boeing 787. Flying almost 24,000 feet above the ground over here. So maybe the most beautiful view, and we need about 7 more minutes to go back to the airport. I'm gonna start descending now. So idle thrust over here and start the descent. We'll increase the airspeed now as we are descending back to the airport. Speed brakes also extended and keep descending. Trim down the aircraft as we are descending over here. Have pretty much 6 minutes left for the flight to end. So you can see now the indications as we are descending at idle thrust here. We have the max speed also, max 0.7, 069 now, 350 knots, cross 17,000 feet, keep descending, you see the needle, 5,900 feet per minute, the descent rate. So we have a beautiful view again of the cockpit. 15,000 feet over here, keep descending. 14,000. So we need to cross through some waypoints now. As you can see here, the waypoints are the plan we need to follow for approach and landing. So we're gonna make the turn now, and we have 4 more minutes left as we descend. We need to use a little bit left rudder now for the approach and landing. You can see the turn over here, how we turn. So keep descending, and we have 4 more minutes left for the approach and landing. Pretty much good time, as you can see. Three more minutes left. Approach and landing over here. So we align with the runway over here. So add a little bit thrust, landing gear down, some flaps. You will see we are approaching full landing. So we're gonna having this nicer view over here for approach and landing. We don't need so many flaps right now until we're gonna be in the final approach. So you can see we flying manually. We have some side wind to combat with. We have some gust, wind gust, and side wind give us some maybe. We need to use full flaps now to maintain stability over here as we are approaching. This is the Lszh localizer, the information of the horizontal localizer displayed also as we approach. in the navigation and in the primary flight display. So we have 1 more minute for approach and landing. We have some side wind. We need to combat the side wind with the flight controls, rudder pedal, also ailerons and spoilers, as you can see. So we align with the runway for landing. Here we are, aligned with the runway. We have the flare over here, gonna flare the aircraft for the touchdown. As you can see, beautiful touchdown here. Touchdown, parking brakes, and thrust reverse. So ease idle and thrust reverser over here, as you can see, to stop the aircraft. So align with the rudder pedals as we're slowing down. So you can see we're slowing down the aircraft. So the aircraft is stopped in the ground. We made a very successful landing. You can see all flight controls. You can see the landing gear down here is perfectly safe. The nose wheel part also is safe. There is no breakouts of any part.